We already know what an atom is, what electrons are, and that electrons are arranged around the nucleus. But how exactly are those electrons arranged? Is there a specific pattern they follow? In today's lesson, we're going to learn electronic configuration step by step using simple explanations, animations, and plenty of examples. By the end of this video, you'll be able to write the electronic configuration of atoms with confidence. So, let's get started. What is electron configuration? First, let's remember something important. An atom has a tiny nucleus at its center. Around that nucleus are electrons, but electrons don't move randomly. They are arranged in energy levels, also called electron shells. Think of these shells like floors in a building. The first floor is closest to the nucleus. The second floor is a little farther away, and the third floor is even farther. Electrons always fill the closest available shell first because it has the lowest energy. How many electrons can each shell hold? Here's the simple rule you'll use at GCSE. The first shell can hold 2 electrons. The second shell can hold 8 electrons. The third shell can also hold 8 electrons for the first 20 elements. So remember this simple pattern: 2, 8, 8. That's all you need for GCSE questions involving the first 20 elements. Let's try some examples. Hydrogen. Hydrogen has 1 electron. The first shell can hold up to 2 electrons, so we place that 1 electron there. The electron configuration is 1. Simple. Helium has 2 electrons. The first shell becomes completely full, so its electron configuration is 1 or 2. A full first shell makes helium very stable. Lithium has 3 electrons. The first 2 fill the first shell. Now the first shell is full. The third electron has to move into the second shell, so the electron configuration is 2, 1. Notice something important. We never overfill a shell. Once a shell is full, the next electron starts a new shell. Carbon has 6 electrons. Put 2 into the first shell, that leaves 4 electrons. They all go into the second shell. So the electron configuration is 2, 4. Oxygen. Oxygen has 8 electrons. Put 2 into the first shell. There are 6 left. Place them in the second shell. The electron configuration becomes 2, 6. Sodium has 11 electrons. The first shell gets 2. That leaves 9. The second shell gets 8. Now only 1 electron remains. It goes into the third shell. So sodium is 2, 8, 1. Magnesium has 12 electrons. The first shell gets 2. The second shell gets 8. 2 electrons remain. They go into the third shell. The electron configuration is 2, 8, 2. Chlorine has 17 electrons. The first shell gets 2. The second shell gets 8. That uses 10 electrons. There are 7 left. They all go into the third shell. So chlorine is 2, 8, 7. The shortcut. Here's the fastest method. Step 1, find the atomic number. Step 2, the atomic number tells you how many electrons the atom has. Step 3, fill the shells in order. The first shell, up to 2 electrons. The second shell, up to 8 electrons. The third shell, up to 8 electrons. That's it. Why does this matter? Electron configuration isn't just something to memorize. It explains why elements behave the way they do, why sodium is highly reactive, why chlorine easily gains 1 electron, and why noble gases are so stable. Everything starts with the arrangement of electrons. Thank you for watching. If you found this video helpful, please like, subscribe, and share it with your friends. Your support really helps the channel and allows me to create more chemistry lessons like this. If you have any questions, feel free to leave them in the comments below, and I'll do my best to help. Thanks again for watching, take care, and I'll see you in the next video. Goodbye.